Ladies and gentlemen, it's my pleasure to have a talk here about the biochar and the circular economy in Taiwan. I'm Shih-Hao. You can call me Jien from National Pingtung University of Science and Technology from Taiwan. First, I would like to introduce the circular economy of biochar in Taiwan. We except for obtainment the energy from this cycle, we we would like to use the biochar to three major parts. First is to be a feed for the poultry. The second is for the soil amendment for sustainable soil quality. The third is for the forest management. We call urban forest, especially in city park. So in Taiwan, we try to combine the circular economy and the agricultural management. We also got four major issues, such as the development of the fertilizer management and the development of innovative techniques to mitigate the climate change. The third is we also focus on the organic farming by using biochar and some compost. And we also focus on the rural village planning and the development. We try to use this biological cycle in circular economy to for the biogas production, for the smart agriculture and the biotechs and the biodegradable materials and the bionics. Uh, we use we have this part. Our final purpose is want to get the clean water and the renewable energy and the sustainable soil environment. Okay, just introduce some biochar circular economies in Taiwan. We have some cases in Taiwan. Uh, in southern Taiwan, the Kaohsiung District Agricultural Research and Extension Stations, they would like to use the furnace to create to micro generation of the electric power in this cycle. They want to get the energy and some heat and the gas and final to produce the biochar and the pyroligneous liquid, so they can get some benefits of the incomes from this cycle. Just like the maybe 1 year they can have about the 10 about the 150,000 US dollars for the biochar and the pyroligneous. And another part, they can get some incomes from the electric power and some heat and the gas. They can get the about 200,000 US dollars per year from this cycle. Also in northern Taiwan, uh, they also use the some furnace. They develop some furnace to collect the residual heat, just like they uh, want to dry the rice husk, and they use the residual heat to make the biochar production. Also, some universities want to develop a new pyrolyzed furnace. That's a continued the materials feeding systems. They can get some biochar and some pyroligneous. Uh, this furnace can control the temperature. So that's the new systems in Taiwan in some universities research. Okay, some company or universities or use this biochar to be some adsorbent to reduce the ammonium nitrogen and the nitrate nitrogen in the water of the cultivation industry. Also, some universities to develop of the biomass pellet fuel. They they can produce the 1,000 tons per year and create about the 13 millions NT dollars per year for this pellet fuel. But in my expert, I would like to focus my study in the soil environment, and my purpose is to reduce the agricultural wastes and increase the crop production by biochar, and then to finish the circular agriculture and then finish this circle. So I would like to study the soil quality regarding physical properties, chemical properties, and the microbiological properties after biochar application. And I also want uh, to check the soil carbon sequestration for the after biochar application. And I would like to evaluate the erosion and the runoff control by biochar application in sloped Why we want to use the biochar in Taiwan? Because in Taiwan, the soils uh, uh, are poor with the soil organic matter. The soil organic matter content is about the only 2% or below 2% in soils in Taiwan. And also the soil is very acidic in Taiwan. It's about the 4.5 to 6.5 in Taiwan rural soils. So that's why we would like to use the biochar in the rural soils in Taiwan. Just let's check a biochar structures for the low temperature biochar and the high temperature biochar. For these two temperatures, the biochar structure is almost similar. Just only difference between the pore size and the pore density for the different temperatures. The low temperature biochar got larger pore diameter, and maybe the density is uh, not is low, a loose density for the pore distribution. We also use the NMR to check the functional groups for the low temperature biochar and the high temperature biochar. Uh, there is the aromatic carbon and the amines may be dominant in high temperature biochar, and uh, oxygen alkyl carbon is dominant in low temperature biochar. Also, we can also find the high pH in high temperature biochar. But for these two temperature biochar, the nitrogen and the phosphorus is very poor, but they are all rich in potassium for these two temperature biochar. So we use just only a high temperature biochar for our study. We use the 2% biochar into the red soil, the high weathering soil, and the mixed homogeneous in the surface soil, just like this. And just after 1 year, we analyze the soil physical and the chemical and the microbiological properties for the all treatments. So you can find after 1 year, the for the treatment with biochar and the compost and the all core applications with compost and biochar together, you can find the bulk density decreased obviously, and the porosity increased about 4% for the core application with the compost and the biochar. The aggregate stability is also increased very obviously for the amendment addition, and also penetration resistance also decreased, particularly for the biochar and the co-application with composite and biochar. Okay, you can check the soil aggregate situation in this slide. The control after a year is uh, very few soil aggregate, but in treatment of the biochar 2%, you can find the a good soil aggregate after 1 year. If you co-applied the biochar and the compost together after 1 year, you can find a very beautiful soil aggregate in these treatments. This is the chemical agent PAM. Also can find some good soil aggregate. Okay, let's take a look for the water retention for the treatments. You can find the co-application of the compost and the biochar, the very good water retention ability can be found in these treatments as co- uh, as compared with the control. They can increase at least 15% of the water retention ability for the biochar and the compost application together treatments. Okay, let's take a look for the change of the soil aggregate under the microscope. You can find after 1 year, the biochar and the compost application can effectively to combine the soil particles to form the circular aggregate in the red soils. We also use the CT to check to evaluate the soil pore and the connection, the changes between pores and the connections. You can find the black color part is mean pores, and the white color part is mean the solid. If you added the compost and the biochar together into the soil after 1 year, you can find the pore number increased very obviously from 4,000 to 17,000. Also, the connection channel we call salt also increased obviously in the compost and the biochar application elements. So for our studies, we confirmed the biochar can reduce the run of water and reduce the soil losses and reduce the nitrogen loss and increase the yield for the crop production. But we need to have a further study for the phosphorus losses situation, because we don't want to uh, we don't want the phosphorus losses in slopland. So this situation need to be further studied. Okay, we also published some our results, our studies. The biochar application not only increase the soil aggregates and also porosities and the good soil quality, and also some microbiological properties. Just like this, you can find uh, the porosity increased, and in organic nitrogen contents increased, and the soil organic carbon increased, and the pH also increased, and also mean width diameter of soil aggregate also increased obviously after biochar application into the soil. So they changed the microbiological structure communities in this soil also. You can find some gram-negative bacteria and some Clostridiums nitrophenolicums bacteria in the soil. These two bacteria is a good species in the soil for the nitrogen decomposition and some good react. Okay, we also found the biochar application in the soil can obviously keep the carbon in soil and decrease the CO2 emission in the soil within 2 months, about 17% to 20% CO2 emission. The biochar can control the emission to atmosphere. So we also check the crop production for in situ experiments. So we use different biochar and different ratio of biochar and combine it with the compost together into the soil to check the crop production. We can find the, the crop is production, the harvest is very good for these treatments. The about 2% biochar and 0.5% compost. This treatment is best for the water spinach about the 20 days. Not only the first harvest, but also second harvest. Uh, the This treatment is also the best for the highest yield, about 15% yield compared with control in the second harvest. The 0.5% compost and 1% biochar. We also make the biochar and compost together to be a biochar control release fertilizer to be this shape. That's the diameter. Average diameter is about 1 centimeter. We also use this into the field to check the crop production. We use the also spinach for about 1 month. You can find this ratio BCI is the good for the growing of spinach. It's B biochar 25%, compost 75%. This treatment is best. So 75%, 25% compost and biochar is the best one to increase production, about by 50% to 100% compared with the control. But we need to notice the available phosphorus within 30 days, particularly for the first harvest, because the within 30 days the available phosphorus the amount is not enough for the growing. Okay, so our conclusion is biochar is a good materials for the circular economy for the agriculture, and it could effectively reduce the input sediments for the catchment or in the reservoirs about the 20% for 40% input sediments, and it could be a amendment to effectively reduce the eutrophication phenomenon to reduce the nitrogen and phosphorus and the potassium through the runoff, the erosion, about 1% to 50% in reservoirs. Also, compound biochar fertilizer could effectively increase the crop production about 50% to 100% for water spinach. However, variable phosphorus deficient should be conserved in the initial stage within 30 days. Thank you very much. It's my talk. Thank you.